Well, hey guys, thanks for stopping by the channel, where I'm going to show you how to recreate the colossal crown molding you saw in this video's thumbnail. I really don't have time to push pause on other video projects going on here in the shop, but as some viewers know, I've kind of gotten sidetracked by some laser engraving projects, and I wanted to get back into some true next level carpentry, and I think replicating this colossal crown molding really fits the bill and involves some true next level carpentry. So I'll take you to the job site so you can see the colossal crown molding I'm replicating and show you the first step in the replication process. Well, this is the colossal crown job site. As you can see, there's some remodeling going on. Part of the remodel is replacing bookcases that were here. These were 12 inches deep. They're going to be 18 inches deep. So this soffit needs to be built out, and the crown molding needs to be moved out to the face of those cabinets, like in this picture from my SketchUp planning model. And even if this was wood crown molding, this crown molding needs to be moved out, and because of the angle of this wall, the new piece of crown molding needs to be about 6 inches longer than the existing. But because it's plaster crown molding, I can't even take that piece off and extend it. I've got to make a whole new piece, which is the purpose for this whole colossal crown video in the first place. And with that as an overview, the first step in the colossal crown replicating process is to make a template that matches the profile of the existing crown molding that I can use for replicating that profile in wood. I apologize that the lighting's not very good in here right now, but that just proves to you that this is a job site and not a video production studio. But when looking at this colossal crown, you can see that there's a lot going on. A step, a cove, a step, a swoop, a step, another step, a bead, a step, and another step. And it's a very attractive molding for this room, plus the fact that it's made out of plaster, it'd be really difficult to remove. So that's why all this crown is staying, and I'm just going to modify it. And with this view, I can show you that this soffit and this crown is going to move out to about here. It's about 5 inches out. So I need to make a new piece that goes across this way parallel to this one. This will just stay in here. Part of this gets removed because the front of the fireplace gets changed. But what I want to do is capture this profile, and this is a good place to do it. So I've just got a piece of this floor protection cardboard. This is about like the cardboard you get on the back of a legal pad. And I'll just use it to replicate this profile in cardboard so I can use that to recreate this in wood. And I'll start by taking two key measurements: how far out this projects from the wall and how far down it drops from the ceiling there. And I'll just do that with a tape measure and a speed square, like so. And I'm getting about 4 inches out, 4¼ inches out, and about 6 inches down. And I'll lay out those two dimensions on this piece of cardboard, assuming that this is the corner between the ceiling and the wall. And with those two marks made, I'll use a speed square to connect them into a rectangle of those dimensions. Because I know there's a step of about 3/8 of an inch down from the ceiling and out from the wall, I'll mark that dimension along two sides of the template, connect them with a rough angled line, and use a snap blade knife to rough cut that shape out of the corner of the template for a first step. And if you're lucky enough to have a friend with a 3D printer and knows how to use it, you might end up with a slick carrying case for spare 9mm snap blade blades in case you snap one in the process. This part of the process is a little bit sketchy, but you can see I've just taped this rough template up here about this distance away from the wall, so the template needs to just slide in. And I can just take this little piece here using a shim and roughly trace the profile of the colossal crown on the piece of cardboard to dial in the contour. And even a squiggle mark that's only that good is good enough to proceed with the templating process. Next, I average out the line with the Sharpie marker for a little better guide as I cut, and use that snap blade knife to trim the profile to this rough contour. After rough trimming to my rough line, I take the template back in place and trace a new profile, but this time using a 1/2 inch chisel as a guide for a 1/2 inch offset cut of the template to meet the crown. This process looks a lot more tricky than it is because I've got the camera shooting over my shoulder and I feel like I'm working left-handed, but I've got a new contour line traced that'll get me closer to the end goal of a perfect fitting pattern. So after averaging out my sketchy line again, I refine the contour again using the snap blade knife to dial it in. And you can see that after my third attempt here that this template is pretty darn close to that profile. There's a couple little gaps in there, but another trimming will clean those up. And I won't bore you with the process, but show you this piece, which is the actual template I'm going to use for the replication process. It's all dialed in, fits like a charm. So I'll take this one back to the shop and work with it. So that's the tracing and trimming process that I used to end up with this template. There's very little difference between the one I'm just doing here in the video and this one, but this one I can take to the bank, and I will. But I wanted to give you an overview of the process of how I got that done. Now, if you can get one of those little slidey gauges, those contour gauges, that's wide enough and has enough reach to do this, you could sure do that and copy most of that crown. It'd be a shortcut rather than the purely analog way that I used here to get this. But it does show you how to go about it and what's possible, regardless of the profile of the particular colossal crown you might be trying to replicate. So I'm going to head back to the shop. With my negative profile pattern in hand, the first step in the shop is to create a positive profile that matches this contour exactly, and I'll do that at the bench. I'll create a positive pattern on this piece of thin white cardboard here, so I'll tape it down in the corner of a framing square, and then I can take my negative template and place it in here. While I'm doing this, I determined that the crown molding projects 4 inches out and 6 1/4 inches down, which is nice round numbers, and I imagine the craftsmen that did the plaster crown molding back in the day used those dimensions on purpose. With that in place, I just take a superfine Sharpie marker and trace the negative onto the white paper to create a positive. Simple as that. The next step is to determine how thick of a piece of wood I need and how wide that piece needs to be to contain the entire profile of this colossal crown molding. So I remove the framing square, tape the positive profile down, and use steel rules to figure out those dimensions. And it looks like 1 1/8 is the absolute minimum thickness I'd need. But the obvious problem is that at 1 1/8, there'd be no thickness left in this part of the crown molding. So the piece needs to be thicker so that the finished molding is strong enough to cut, fit, and install. And with that in mind, I can replace the rulers and determine that a piece about 1 5/8 thick would leave enough thickness or strength at the middle of the molding to do this all in one piece. But if I use a piece that's that thick, I've got to remove an awful lot of material from in here to accomplish that profile. So I'm going to take an outside-the-box, next-level approach to this problem and make this colossal molding out of 6/4 stock, or stock that's 1 1/4 thick, by putting a beveled splice joint in there, so 2 halves of the colossal molding can be made out of that thinner stock that'll look like this. And although I'm adding the complication of a joint in the middle of the piece, I'm using less material, but more importantly, I have to remove less material for the same end result. And I'll add this shot to kind of show how this concept works with my original negative profile there, and this piece planned out using 6/4 stock in these 2 segments, which I'll make out of some 6/4 poplar, with this profile on one piece and that profile on the other, and this bevel joint in the middle, so that I end up with a rigid piece of crown molding that I cut, fit, and install. Since it's unlikely that anyone will ever reproduce this exact colossal crown molding, I'm not going to go through all the gears of how I determined the angles and the position of these pieces, but basically I took some scrap of material, I cut to 1 1/4 thick to match this 6/4 poplar that I bought, and I just positioned them to cover up the profile so there was enough thickness left over and I wasn't removing so much material to create the profile. And for this particular molding, again, this is 1 1/4 thick stock, and I ended up with a 26-degree angle, so those are cut at 13 degrees, and then that's positioned precisely at that spot in the profile to make everything to come together. But in many cases, or it might be your preference to just use thicker material and remove more material to get the whole thing done in one piece without the extra complication of this miter. But that's what I decided to do. And now that you know how I got from here to here, let's go over to the bench habit for the next step. Here at the bench, I have my working model of the negative profile with the 13-degree angles laid out there, and here's the piece of what the actual molding will get cut out like. It nests right in there, perfect positive and negative profiles that match up there, and the optimized layout of those angles on these pieces. And in the bench habit here, I've clamped 2 pieces of that 6/4 stock. One is wide enough for each of these 2 segments of the crown molding. And all I need to do here is lay this out on there so it gives me a profile to follow. And I'll start the tracing process by just using this 13-degree angle block, drawing a cut there and a cut on this piece, allowing myself just a little bit of margin between the edge of the wood and that line. And then I can trace the actual profile of the 2 halves by lining up that angle mark and just following the edge around with a super sharp Sharpie marker. And I repeat the process for both segments of the Colossal crown, just like that. And you can see how the profile fits within the confines of that piece of wood in a fairly efficient manner. These points will just barely fit in the 1.25 inch thickness there. It's all good. I do have a rather deep cut here, but this fits within the confines of this piece of 6/4 stock. And the benefit of taking this approach is that I've got these 2 sample scraps to plan out the profiling process, which is a lot easier to do as short pieces than the full length pieces I use for making the crown itself. With all the layout, planning, and verifying I've done with cardboard and short pieces of stock, I can confidently rip the 2 long strips I need for making the Colossal crown out of the slab of 6/4 poplar I got for the project. After ripping the long blanks and short setup blocks, I'm ready to start the actual profile shaping process. As I mentioned before, since no 2 Colossal crown moldings are ever going to be identical, I'm not going to get into particulars of dimensions, angles, and radii for doing this process, but I do want to cover some of the basic methods I use for creating complex profiles on moldings like this. And the first one is basic and advanced ripping steps on the table saw, where I'll be using a thin kerf ripping blade for the basic angle cuts, and then I'll switch to a full 1/8 inch kerf ripping blade with a flat bottom cut for some of the advanced profile shaping steps. When it comes time to shape some of these coves, I'll use core box bits in the router lift to create those coves, because it's a pretty straightforward process for the symmetrical coves in the profile. But I'll also cover plowing the big cove here using the table saw, because even though it might not be 100% necessary in this particular profile, it's often the only method I have for cutting deep, wide coves in a molding. In addition to those cutting steps, I'll also make custom shaped scrapers for defining and refining some of the curves. And as you might suspect, I'll finish up the process with copious amounts of sanding and detail scraping for final shaping and cleaning up the profile so that it's ready for paint. And with those methods in mind, I'll start with some low-hanging fruit by making simple bevel cuts on the blanks using that rip blade in the table saw. To determine the correct angle settings for making these various beveled cuts on the blanks, I used a protractor square while the blanks were still clamped in the bench habit to measure the degrees of angle necessary for making each of those cuts. If you can see this in the camera, this cut is 17 degrees, that one's 90 degrees to it. These 2 cuts are at 24 degrees. And on this piece, the top cuts are 45 degrees, where this line here is at 43 degrees. And that will change from project to project, but by using the protractor square and lining it up on those profile marks from the profile pattern, I can easily replicate any angle necessary to create the finished profile. The nature of this profile and the orientation of the angles and the shapes of the coves required to recreate it mean that I'll be running these pieces through the table saw and over the router table in various directions and various orientations. So to avoid a mistake that's very easy to make, I use orientation marks on both the scraps and on the work pieces so that whatever direction or position I run the test piece through, I can replicate that with the actual piece. And I'll start out with some low-hanging fruit by cutting a couple easy angles on the narrow piece for the top segment of the Colossal crown. And the first piece of low-hanging fruit I want to grab is a nice juicy red Macintosh apple right here in this little shoulder on the bottom of this upper cove. And I measured that angle to be 43 degrees relative to the face of the block. Now I'd love to cut this with the piece laying down on the table saw, but my table saw is not going to go to the reciprocal of that angle, so I've got to make the cut with the piece standing on edge and the blade tilted to 43 degrees off of perpendicular, which is the way the blade angle setting is measured on a table saw. As it turns out, that delicious red, ripe, low-hanging fruit turned out to be an apple with a worm in it, because in order to make this cut that I want to make with this setup, I've got to raise the blade all the way up, and that makes for a very scary cut, which I would be willing to do, but even at that, I can't raise the blade high enough to complete the cut with this setup and this orientation, so I'm going to regroup and make a different first cut first by finding another piece of low-hanging fruit without a worm in it. And I'll choose this 45-degree bevel cut on the very top of the profile as the first pass on recreating this molding. And I'll start by changing the angle of the blade from 43 degrees to 45 and lowering the blade to the appropriate height for this cut. Because my table saw is a right tilt model, I switched the camera to the infeed side so I can line up the blade with the cut mark and the fence with the block for making this cut. And I'm just using the old reliable standby eyeball method to line things up and make the cut in 2 passes so that I can dial it in exactly where I want it on the blank. With everything set up and safe, I make this bevel cut in 2 passes, where the first cut is an approximation, followed by a slight readjustment of the fence, and a second pass to put the cut exactly where I want it. Once I'm completely satisfied with the bevel cut on the test block, I use those bold orientation marks to reorient the workpiece so I can make that bevel cut along its full 8-foot length in one smooth, confident pass. Notice that I'm using a pair of my Grote tangent ramp outfeed roller stands, one on the infeed side of the saw and one on the outfeed side, to support the workpiece while I make this long beveled cut. The roller stands make it possible to make this long beveled cut straight and smooth without burn marks, which is tough to achieve if working alone in a shop without them. And the results I get when using this process and setup speak for themselves. I decide to tackle some of the basic bevel cuts on the lower section of molding, and I'll start with this little 17-degree bevel that forms the flat spot where the molding gets nailed against the wall. And to do that on this saw, I've got to flip my unifence around and cut on the opposite side of the blade to keep the blade from digging into the rip fence. And that's easier than putting on a sacrificial fence for just one operation. And here, once again, after everything is set up with the test cut, I double check orientation of the workpiece and put that same 17-degree bevel all along the bottom back edge of the lower section of the Colossal crown in one smooth, clean pass. With the blade still set to a 17-degree bevel, I flip the fence back to its normal orientation, reset the blade height, and reposition the fence and make another cut to establish the face of the very bottom section of the Colossal crown. With that bottom cut complete, I'll reset the fence, angle, and depth of cut to create this little face here with a setting of 24 degrees off of vertical. This cut requires a very high blade setting with a lot of exposed blade, but the workpiece is big enough and the cut is contained, so I don't see it as a dangerous situation. So with setup complete and orientation verified, I make this third cut with confidence. Because this adjacent cut uses the same blade angle, only different orientation of the workpiece, I'll make that next on the lower section of the Colossal crown. As before, I do the initial setup by just eyeballing everything and sneak up on a final cut by adjusting the fence and blade height till it's exactly where I want it to be. It usually takes a few passes with a few adjustments, but it doesn't take long to dial in the cut to exactly where I want it to be. So I can switch from the sample test piece to the actual workpiece and make the long rip to complete this step. With all the basic bevel cuts made, I'm going to revisit that wormy apple and tackle that little flat spot that I couldn't reach with the 10-inch saw blade at full depth, and I'm going to do that using a dado blade. The flat spot on the upper section of the Colossal crown is just over a ½ inch in width, so I've set up my Forest Dado King dado blade to a width of 5/8 of an inch so I can make that cut all in one pass. And I do that by tilting the blade to the 43-degree angle for the face of that cut, so the bottom of the dado cut will establish the face. At the same time, I lower the blade below the surface of the table saw top, put a blank insert in my zero clearance throat plate insert, power up the saw, and raise it up through that insert to both locate the cut and give me a nice clean cut in the face of the molding. Now I use a pencil line drawn at 47 degrees to the face to line up the edge of that dado cut in the zero clearance insert, which in turn lines up the cut with the profile drawn on the end of this test block. I purposely set the dado blade a little bit low so I can sneak up on the final depth of cut in subsequent passes. It takes a half dozen cautious attempts, but the end result is exactly what I'm looking for. As I use a dado blade to plow this long angled notch, I admit I'm really picking at nits with these angle settings. It could have made things a lot simpler if I just cut this with a blade at 45 degrees, because, truth be told, a plaster artist from long ago was probably using a 45-degree angle as he troweled that molding to shape. But I hope this segment demonstrates that these methods are very flexible, and it is possible to make off-angle notches and cuts by keeping an open mind with the blades and setups you use to recreate any colossal crown profile. I admit that progress after these initial cuts doesn't look like much, but this is very typical of recreating a molding like this, and it emphasizes the fact that sequence is important, because these cuts are harder to make after there's curves and irregular surfaces involved. And to that end, I kind of got myself in a bind by making this 17-degree angle cut up from the bottom of the molding. My intended sequence for the bottom of this segment of the molding was to cut the 17-degree angle on the bottom first and then wait and do this 17-degree angle cut. But because I got ahead of myself in the sequence, I've made it more difficult to establish this small curve here because I won't have a solid corner here to register off of. It's not a total fail, and I'll be able to get it done, but it will involve a little more complicated setup when I get to the point in the profiling process where I'm making that little bulge on the bottom of the molding. But the good thing is, it's not a deal breaker and I don't need to start over. So I'm going to climb a little farther up in the tree where there's ripe fruit that's not low hanging and tackle the cove in the upper section of the colossal crown next. I can tell you that I was thrilled to discover that the cove on this upper portion of the colossal crown has a radius of exactly 3/4 of an inch. And I'm also equally thrilled to report that I have an 1.5 inch core box bit, which is based on a 3/4 inch radius, that will work perfectly for plowing that cove through this molding. And because a dado blade is so much more efficient at removing material than even a good router bit, and as long as I have that dado blade still set up in the table saw, I'm going to remove the bulk of the material in that cove using a dado blade in one pass before getting set up with the router lift to finish the job. And what's arguably the easiest operation in the profiling process, swap out the insert on the zero clearance throat plate, then raise a dado blade up to set the height and reposition the fence for plowing this dado in the center of the cove cutout. With everything set up, I do a quick test cut on the sample piece and then fearlessly plow that groove through the entire length of the upper colossal crown workpiece. Sweet! As you'd expect, it takes a few minutes to reconfigure everything here in the shop with the fence moved over. I've got the MLCS PowerLift Pro router lift set up. I've got that 1.5 inch core box bit in there. I've set the bit height so that it's close to taking out that full cove, but as usual, I'll do this step in a number of passes, kind of sneak up on the final mark, and I do that by changing the bit height setting with a tablet here with the MLCS PowerLift Pro app installed on it. And I've done other videos where I talk more about the lift itself, but I'm not going to go into that rabbit hole here. But I do want you to see that I keep basically every option I can think of on the table for getting this job done quickly, efficiently, and accurately. And so switching back between saw blades, dado blades, router bits, etc. to carve that profile, it's all acceptable, and it's definitely desirable when it gets the job done by deploying basically every tool in the arsenal to the task at hand. So let me bring the camera down close and show you what this whole business looks like. I've got the router bit set up crossways here so the full profile is exposed to the cut at hand. And I've got the fence set so that the router bit is basically centered up in that cove, and the bit depth is about a good 1/16 of an inch shallow of my final Sharpie mark on the wood. And I adjust that setting. I'll do this with the PowerLift Pro here. This is what it looks like if I drop the bit a 1/4 inch and raise the bit a 1/4 inch, so I know where I'm at with this cut. I'll fire it up here in a second and make an initial pass on both the sample block and the workpiece, and then I'll adjust that bit height setting on the test piece and make a second and possibly third final pass on the workpiece to complete this step. And here we go, fire in the hole. And that's what I get as a result after that first pass. It's just a little bit shallow, but boy, that's a perfect cove. So I'll run that first pass on the workpiece and make adjustments. Before starting the operation, I double check orientation of the test piece and the workpiece to make sure I'm not making a big mistake. Then fire up the router and let it come up to speed before making the cut. I'll point out that I make a conscious effort on an operation like this to keep pressure on the workpiece down on the table and in against the fence, because if the workpiece wobbles, the cut wobbles and has the potential of spoiling the piece. And here, once again, you can see how those Grote tangent ramp roller stands make the whole process a simple operation, even when I'm working alone. With the first pass complete, I use preset movements on the MLCS PowerLift Pro app to adjust the height of the bit, starting by raising the bit a 32nd of an inch and subsequent adjustments until the depth of cut and the cove profile is where I want it. I go through the adjust, test, and adjust steps as many times as necessary to get perfect alignment between the router bit and the cove outline, and once everything's copacetic, complete the finished pass on the test piece. And with that router lift in this setup, getting perfect results is a routine process. So I'm ready to commit and plow that 3/4 inch radius cove along the full length of the workpiece. I use the same slow, steady feed rate and even pressure used on the test piece. Keep the cut straight and smooth, without burn marks or chatter marks, compromised feed process, and result from an unsteady feed rate and pressure. When the router spools down, I can say that I'm pleased with that cut. Came out nice. And I'm inclined to think that you'll agree that this Colossal crown profile is coming along quite nicely. And as I advance to the next step, I want to mention that there's a portion of this sweeping curve on the lower part of the Colossal crown that could be shaped pretty easily using that same 1.5 inch core box bit. And even though that's an obvious solution for this, and if I wasn't making a video, I'd probably use it, but I want to demonstrate another option for making curves when you're not so lucky as to have a simple router bit do the job. So I'll hold off on shaping this cove for now and tackle this shallow bulge in the upper piece of the Colossal crown using a dado blade because it's still set up in the table saw. And I'll do that in a number of faceted cuts, starting with the dado blade set to 30 degrees, then 20, then 10, with adjustments in the depth of cut in between each of the passes. And the goal is that each faceted pass creates a flat spot that's tangent to the curve drawn on the test piece. As you can see, each subsequent pass over the dado blade creates another cut tangent to the sweeping curve that I want to end up with. And even though the changes are subtle, the results are productive. After I complete a pass with the blade angle set to 0, I have to reverse the direction of the workpiece to make subsequent cuts on the profile because the tangent angle of the curve has passed the center point. And I proceed by making subsequent passes at 10, 20, and 30 degrees to finish up the sweeping bulge. After making the pass with the blade setting at 0, I reverse the feed direction of the piece and make a final pass with the blade angle set to 15 degrees to complete this phase of the Colossal crown shaping process. And once again, I think you'll agree that that's coming out rather well. And before I leave this shot, I want to point out that it's not an accident that there's a full lug of material going along this side of the molding as well as this side, because I want the workpiece to be able to lie flat on the surface while making these cuts. And if that lug was gone, the piece could rock and tilt. And using this sequence, it's super simple to make a final angle cut with a rip blade in the table saw once the profile shaping process is complete. Even though you and I can clearly see this colossal crown molding taking shape, the YouTube algorithm tends to overlook long, deep dive, in-depth videos like this. So I'm going to ask if you'd consider subscribing to Next Level Carpentry if you haven't already. And if you like the content, hit the thumbs up button, because at least that has a chance of getting the attention of the quants over there at YouTube to promote videos like this, showing content that you'll never see on HGTV. And although I'm not really focusing on any of the brands or products that I like, use, and recommend here on the channel, you can find links in the video description for those products with that Amazon link, and any purchases made through those links help support the channel with small sales commissions from that activity. You can check out Teespring for signs, posters, and t-shirts and swag from the shop. There's a link to that in the video. And although I'm not really featuring products from Starbond in this video, I use them every day in the shop, and there's a link for 15% off using the code in the video description. And I'll wrap up with a special shout out to patrons of Next Level Carpentry on Patreon, because members of that above and beyond group really are the backbone of support for a channel like this, where I focus on content more and promotion less, because their monthly patronage fills in dips and gaps in ad revenue and sales commission when I'm working to produce long deep dive videos like this. So if that's something you're interested in doing and want to see more deep dive niche content like this in videos from the channel, scroll down to the link to Patreon and sign up if that's something you're interested in. And with that out of the way, I'm going to advance to the next step, which is the most advanced profiling technique that I'll use on this molding. And I think it's important because it's a useful, versatile, and powerful method that I deploy on complex projects like this. And I think you'll find it informative, if not equally useful, on projects you might find yourself faced with. Well, I've reconfigured the shop from that last operation where I was using the dado blade, and I've put a rip blade with a flat bottom cut on it in the table saw, and then set up these guide rails for plowing that long, somewhat asymmetric cove through the face of the lower portion of the colossal crown molding. And I'll add a link to a video I did over here that gets off into the weeds about particulars about making this kind of a setup, so you can check into that for things that I'm not including here in this video. But the general idea of this process is to set a couple of guides at a given angle with the blade set to a certain height to plow out that cove. And it gets done in multiple passes by lowering the blade and then raising it incrementally after each pass. But to give you a general idea of the concept, I'm going to put the camera down here and talk about how I establish this particular angle and the position of these two fences for this particular cut on this particular molding. For this shot, I repositioned the camera so you can see the blade and the workpiece from a different angle. And what I hope you can see is that by changing the angle of the workpiece relative to the blade, the shape of the cove changes. And it gets narrower and narrower and somewhat parabolic as I spin around the workpiece till it's running parallel to the blade, where obviously it just cuts a slot. But in between 90 degrees perpendicular and 0 degrees parallel, the shape of the cove left by the spinning blade changes accordingly. So for this particular cove, I want to cut as much of it as possible in one pass. So I start out by setting the blade height to the depth of the cove, and then just eyeballing this from about the angle where the camera is until visualizing the outside diameter of the blade lines up with the contour line drawn on the piece of wood. And that's the process I used for establishing this angle to cut this cove on this piece. I put some reference marks on here before, so I can just position this second fence parallel to this one so that the workpiece slides smoothly but securely in between those two fences. And with all this set up, I just clamp these two fences down so they stay securely in position during use. And understand that this whole operation is equal parts art and science. So the better you are at the art of kind of picking a general setup for this, the better you'll do at the science of actually making a creative cove cut like this. And both the art and the science get adjusted along the way as I make subsequent passes, but I know I'm in the ballpark with this setup, so I'll just lower the blade down and start off with a first pass about 1/8 of an inch deep, and just make sure it's in between the lines scribed on the end of the workpiece. The closer I get to the completed cove, the more attention I have to pay to the exact position of the fences and the angle of the cut. And because once the cutting passes are done, I've got to sand all the saw marks out of this. As I get closer to the finished cut, I slow the feed rate and take multiple passes at the same setting to make the cut surface of that cove as smooth as possible to minimize the sanding. And now that you have a general overview of how to make this setup and what it looks like, I'm just going to let the camera run it fast forward while I make the initial passes and hug out a bulk of the material that needs to be cut away to shape that cove. Naturally, if I wasn't shooting video, I'd have the dust processor running. I'd be wearing a dust mask for this. It's getting a little dusty in here from all that, but the cove is coming out excellent in my opinion. And I'm really pleased with what was basically a wag for the settings on this, because this cove is very, very close to the contour line that I drew on the end of this piece, which I think you can see in this close-up view. Just barely see that Sharpie mark out here. That is just pretty excellent. And I think I might shift the fence over that direction to move the cove closer to this side and leave the line on this side. And I'm not going to waste any money on a lottery ticket this week because I just used up all my luck making this setup this accurate the first time through. So I'll make that adjustment and run a final pass to finish this up. Because the shape of the cove is good, that means the angle of the cove is good. So this is a real easy adjustment to make. By moving one fence over about 1/16 of an inch, sliding the workpiece over to touch the fence, and then sliding the second fence over to touch the workpiece, which quickly offsets that cut, approximately the desired amount. I use heavy pencil lines drawn in the cove cut as a visual reference to the effects changes to the setup have on the cut itself. Once the fences are adjusted, I'll take a cautious pass to see the effect of the adjustments on the cut and make further adjustments accordingly. And by looking at marks in the cove after that adjustment and that cut, you'll see that I haven't run out of luck yet, because this a little anomaly here in the back, I think that might have to do with my cardboard pattern and the tracing of it. I've got a nice clean cove with a perfect tangent transition between those two cuts. And that is a good thing, because this is a final pass and I want the surface of the cove to be as smooth as possible. I run both the workpiece and the test piece for a second pass over the blade with a slow, steady feed rate to get a finish that's as smooth as possible and will require the least amount of sanding. So now I can make that final adjusted cut on the actual workpiece and finish up this part of the Colossal crown replication process. Woohoo! And before I switch gears, I'll make one final comment about this process, and that is that this side of the molding still has a full thickness lug on there. That's so that this piece rides over the blade without tilting. If I didn't leave enough material on that edge and the blade cut this, the molding would tip, it would gouge the molding and ruin the cove altogether. So pre-planning to leave a little extra material is key to success when replicating complex compound coves and curves on a colossal crown like this. To recap, at this stage, the upper section of molding is just about done with just a couple simple, straightforward rips to finish that. And with the cove completed on the lower section, the next step is to do the small and micro bulges near the bottom of the molding here. So I'm going to set up to do that in a minute, but earlier I mentioned that I got ahead of myself in the cut sequence, and I made this cut from the bottom of the molding first, and that I would have to deal with that. There's a few ways of doing it to keep things simple as I move forward to finish those those two bulges. The solution I decided for that, cutting that slot, was just cut a strip of scrap wood, and I'll glue it in there to support the pieces during the process by keeping two full thick edges, and then that spline will just get cut away later. And I chose that solution because it's just the most simple and straightforward at this point and keeps the project moving ahead. And it also is like being able to press Control Z in the workshop and go backwards, and allows me to move forward and pretend that I didn't actually screw up that cut. And a fix like this on a piece of real wood in the shop is about as close as you can get to the ability to press Control Z on a computer, because it's so easy to press rewind and make the mistake virtually go away. Gluing a spline into that slot is basically a reset that allows me to continue shaping the lower section of the Colossal crown, because it gives me two edges that are coplanar so that the piece doesn't rock as I'm making the progressive cuts to finish shaping this molding. And I've already started the process of shaping the two beads that are on there. So let me bring the camera in close so you can see what it looks like and how I'm doing it. And this is the end of the test piece here with the Sharpie line that I drew on here initially. And you can see I've started shaping the larger of the two beads that need to be done at this stage. And I'm using the same thought process and methods to shape this bead as I did to shape the large bead on the upper section of the crown, only in this case I used a dado blade to create larger flat tangent points to make the curve. And here I've switched to a full 1/8 inch curved ripsaw blade with a flat bottom grind that acts essentially like an 1/8 inch wide dado blade. And I've just made subsequent passes where the bottom of the cut left by that flat top grind is just tangent to that curve. You can see it a little more clearly on this end of the piece because I don't have some of those test cuts going. And I left space in between these cuts so that you could see how they're individual cuts made at different angles. But in practice, I'll just make subsequent cuts that clean all those fins off and leave a slightly faceted face on that convex curve. And I added light and zoomed way in so you could see this shot where it's still set up for doing the last pass with that 1/8 inch blade. And I hope you can see that. The bottom of the tooth, or the bottom of the cut made by the tooth, makes a cut that's just tangent to that line. And the saw is set to a 35-degree angle to get that done. I made that pass on there just like that. And it's leaving this cut behind. When you turn it over, you can see that that's the cut it made. It's this last groove along the edge here. And I had to make a couple of test passes to get it dialed in by setting the blade height and adjusting the fence. But it's the same process as before. It's a little more particular because the radius of this convex curve is so small. But that's all there is to it. And the more passes I take while changing the angle in between the passes, the smoother that curve will come out. And I'll leave the shot set up with the focus and lighting so you can see what it looks like as I make that first cut on the actual workpiece after getting it dialed up and set up on the test piece. And as with all the other steps, it's imperative that I'm feeding the stock in the same direction with the same edge up against the rib fence. And there it is, one cut down and about 10 to go. I spent a couple minutes making adjustments to make a cut to clean out this corner here. I tilted the blade to 45 degrees, I moved the fence, I raised the blade, and you can see that that cut is exactly at the point where this curve meets that face. And that's kind of a significant cut because you can see the effect and the change of it quite accurately. Especially when I flip the piece end for end, and you can see that it establishes that corner between the curve and the flat. So with the blade height, the blade angle, and the fence all set and locked into place, I'll make this crucial full-length cut on the workpiece. And it'll take out that little chunk of wood that's still kind of hanging out in there. And that's one small cut for Matt and one giant cut for Matt Kind. Okay, I know you can do without lame jokes, but I do want you to see it does take a fair amount of time and gymnastics to set and reset blade angle, blade height, and fence position to dial in and cut about a half a dozen more 1/8" dado grooves tangent to the medium bulge layout line to establish this part of the Colossal crown contour/profile. I make each adjustment by eyeballing the teeth on the blade to the layout line and then making cautious test cuts on the short practice piece before committing to making the cut on the actual workpiece. The optics of this will be different for every project, but the process and results should be similar and produce consistently copacetic results. Another important thing to note here is that the more time you spend dialing in each separate cut will pay dividends later when it comes time to scrape and sand these bulges to their final finished shape that's smooth enough to accept a painted or stained finish when the molding is made. Because I hate sanding, I check, recheck, and check settings again before I commit and make each cut on the actual workpiece. So keep this in mind so you aren't mad at yourself for rushing the process and creating more work for yourself in the end. Well, I didn't set a timer for how long the time lapse was timed, but that's what the process looks like. Getting something like this done, making multiple passes on the test piece, adjusting the angle, adjusting everything to get that cut as close as possible. And it's a demonstration of why it's a good idea to have a test piece. A couple of those passes are a little too deep on this piece, but I was able to back off the blade height setting by a crank or a half a crank so that the actual workpiece came out really, really close. And let me show you just how close. In this close-up shot where I placed a little tracing pattern on there, I kind of drew along the edge of this with a Sharpie, but you can see when this all lines up, there's just a little bit of black along that edge, which is a good thing. You can see some unevenness in the cuts here at the end. That's due to feed pressure, how hard I'm pushing down on the piece as it comes off the blade. But the goal is to get very, very close to that line, as close as possible, without going too far. And then the rest of this gets scraped and sanded out for a nice, clean, asymmetrical concave bulge or bead on this part of the trim. So I can proceed with what's basically a lather, rinse, repeat process for shaping the final little bead on the bottom of the Colossal crown. And this is when the sequence of these bottom cuts becomes important, because I need this full edge right here to support the piece as I make these cuts to shape that little bead. And I'll start with a cut that defines the transition between the bottom of the bead and the small vertical face at the bottom of the molding by resetting the blade angle to 17 degrees and making adjustments to the depth of cut and the position of the fence to make this defining cut in a single pass. And it's well worth all the time it takes to get that cut dialed in for a perfect transition at that point. So I can make that cut with confidence on the workpiece. Now I can carry on as before, making adjustments to the blade angle, depth of cut, and fence position to shape this little bead, starting with an initial pass with the blade set at 90 degrees and the depth of cut tangent with my guideline. As you can see, the first cut actually removes a little bit of material while starting to shape that small bead. For a second pass, I set the blade angle to 10 degrees and flip the workpiece end for end to establish a little facet tangent to the black Sharpie layout line. And that pass releases another little strip of wood as the curve takes shape. Another pass with the blade set to 25 degrees, and we're almost there. The final pass with the blade set to 45 degrees finishes the last facet on the curve and releases the final sliver of poplar from the profile. This close-up shot shows you what I got in the profiling process, and I think you'll agree, it's more than acceptably close to the template layout line I was working from. And even though facets are still visible on the face of the beads, that's not a problem because they serve as a perfect guideline for final shaping of those beads in the steps ahead. But for now, I can set up and make two cuts to define the square profile at the bottom of the Colossal crown. And the first cut is a little bit embarrassing because it's actually a redo of the cut I made out of sequence earlier in the video. So what this 17-degree cut is actually doing is just cutting out the spline I glued in to cover my earlier difficulty. And naturally, once the setup is made and tested on the test piece, I commit to recutting the cut on the workpiece, but this time in the right sequence. And that's kind of a deja vu all over again sort of thing. Now, while the blade is still set to 17 degrees, I'll adjust the fence, lower the blade, and trim off the bottom of the bottom piece of the Colossal crown. And how's about that for a finished profile? Now that the tedious task of forming those beads is done, I've got 3 simple cuts left to do. The first one is a 45-degree cut to trim off the top of the molding there. And then I've got the 2 bevel cuts where the pieces join. And I've already got the saw switched around, set up to do that top miter cut. And I'm doing it with the workpiece face up so that the back of the molding is on the table saw top. And the reason for that is so that I get a nice clean cut, because I'm actually trimming off a little bit of the face of this block right here. And if I run the molding this way, once the cut gets made, the piece will drop and it'll spoil the cut. So even though there's a lot of blade exposed here, this is the way I'm making the cut. And then I use a push block to guide the piece past the saw blade to keep my fingers out of harm's way. And I want to mention another technical thing. It's super important that the workpiece is flat on the table saw as this cut is made. If the piece is angling down or angling up, you're going to get an extra amount of blade burn, and it'll throw off the angle cut at the beginning and the end of the piece. And this is where my tangent ramp roller stands come into play, because I can get a nice fit of the piece against the table saw top by dialing in the height just so that the piece isn't being fed too high or too low, but nice, flat, and smooth on the saw top as this critical bevel cut gets made. Once everything's set up, I make the cut on the test piece first, just to make sure I'm not missing something, and then make quick work of ripping that bevel on the full 8-foot length of the actual workpiece. And I am definitely liking that. The 2 remaining cuts are simple and pretty straightforward, but they're very critical, so I want to get them right. And that is to cut a 13-degree bevel on one edge of each of the piece where they join. And to get the setup right, I'm using the 2 scrap blocks of wood that I used in the beginning to plan out the molding, to make sure that I get that angle right. Because when the pieces are joined together, if they're too angled, the molding won't fit, and if they're too flat, it won't fit either. So the first step is to use these 2 blocks to set the bevel angle on the blade. And the mainest thing here is that I don't use the angle guide on the table saw or any other angle setting device to set the blade to a specific angle of 13 degrees, but rather I keep the blade set high and adjust the blade angle till the body of the blade fits the angle on the block perfectly, so that I get a good fit of the bevel when I glue up the molding and avoid any complications with a partial angle of even 1/10 of a degree on both blocks, in case the cut angle is something like 12.95 degrees or 13.12 degrees. And this setup process takes just a minute, but gives me complete confidence that the angle of cut is going to be exactly where I need it. Once the angle is set to my satisfaction, I can set the blade height on the fence to make the first bevel cut on the lower piece of the Colossal crown. And now this time, as with every other time, I make the cut on the test piece first and then run the workpiece through to finish the cut with the same saw setup to get the same result. And that leaves one more cut before the finish line in the fabrication process. And now, after a quick reset and adjustment, I make that same bevel cut on the upper portion of the Colossal crown and get ready for the next step, which is joining the 2 pieces together. Just like that. After cutting the 13-degree bevel on the bottom section of the Colossal crown, I want to double check everything. So I've got my master negative pattern here, master positive pattern there, and I can put the actual cut pieces in place of that master positive pattern, like that, and show you the perfect fit that I get between those 2 pieces. I can put the joint together and slide the combined piece right into place with no fussing or adjusting, so I know that when I glue this, it'll have the right combined angle to fit up against the wall and the ceiling and maintain the profile of the molding itself. And now that I'm satisfied with that fit, I can proceed to the next step, which is going to be smoothing up the beads on these pieces of molding. And I'll do the preliminary steps of that smoothing before gluing this together for an easier workflow during the process. I've set up a glancing light so you can clearly see the faceted faces of the 3 beads on this crown molding, large, medium, and small. And the concept for cleaning those up is pretty straightforward, where I basically make custom scrapers that fit the profile and then scrape until those grooves are gone. I've got 2 of them made here, and you can see the concept that they just scrape away those grooves. Because I left the beads a little bit big, I can scrape off the irregularity till I end up with a nice smooth bead in the end. So that's pretty simple, although the process of making this is a little bit interesting and kind of difficult to show in the video, but I'm going to try. Custom profile scrapers like these are not new to woodworking, and they can be made out of all manner of materials, basically depending on what you have at hand and what work you need to do with the scraper. For a project like this, where it's basically a single use, I'll make a scraper to scrape 8 feet of molding, well, 9 feet, and then I'm done, and I don't expect I'll ever use it again. And for a project like that, I like to use this strapping or banding. This is the stuff they use for wrapping steel or lumber, and it's really tough metal, but it's thin enough that it's easy to shape and tough enough to hold an edge for scraping this. This is just poplar. If I was doing maple, I might have to double down and use a tougher material. But I scavenged this from job sites and stuff, so I have some on hand. I made these 2 scrapers out of this, 1.25 inch stuff. And I've got a piece here that's almost 2 inches wide. And I'll show you the process of making a scraper for the largest of the beads on the upper portion of the crown, so you get the concept and then extrapolate that information if you need to make smaller scrapers like I did for these other beads on the profile. Here's a close-up view of the section that I want to make a scraper for. This is part of the upper molding, basically from this notch here to the joint, which is this section on my positive profile pattern. So I've got this wide piece of material here because it's wide enough to easily cover that whole profile. And I'll start by using a pair of these Midwest snips with the stubby jaws, because they're tough enough to cut this tough metal. And that's saying something about a pair of snips, because that metal is tough. Once I've got the piece cut to rough length, I'll put a subtle curve on one end so I don't lacerate my palm while making or using the scraper. Then I head over to the grinder on my messy bench to smooth out that curve and soften the edges so it's comfortable during use. And before leaving the bench behind, I stop at the anvil on my vise and use a flat-faced hammer to flatten the end of the strap to prepare it for the next step. Next, I use a piece of sandpaper to remove the finish from the end of the scraper that I'll be shaping, so layout lines are easier to see and follow. Because I need a negative pattern of a positive bulge, I use my master positive profile to trace out the segment of the curve I'll be scraping in this step. Then I use the same snips to rough trim the profile and a small drum wheel and a die grinder to fine-tune the profile to the Sharpie line drawn from the pattern. And a note for the wise here, make sure to throw out those sharp steel finger clippings every time you create one, because they can be very painful if you get one stuck in a foot or finger. After rough cutting the scraper, I clamp it down tightly to hold it firmly in place while dialing in the profile with the die grinder. After an initial grind to shape, to take away the burr left by the grinder so I can double check the contour of the profile before refining it. And I'm pleased to say that my first go at the shaping was a complete success, because the contour is an exact match, and I could advance to the next step in making the scraper. For the next step, I use that same small flat file and file both faces flat and smooth, like that. And I double check to see that I'm getting a perfect fit to the profile. So it's back over to the bench vise, where I clamp the scraper in place and use a small smooth file to smooth up the surface left by the die grinder. This is a super light pass, followed by a couple licks with the flat file on the flat angle of the scraper to clean it up as well. After that, I quickly file the faces again to remove any burrs that might have showed up, and finish up using a card scraper burnisher to finish smoothing the surface and to raise a small burr on each face of the scraper. Note here that I'm holding the scraper almost perpendicular to the faces of the scraper, because I want the burr to be flat and sharp, not hooked and curved like on a regular card scraper. It takes more than a few licks to raise a burr, but not as much as many to put the crisp, sharp edge on the profile that I need for scraping poplar. And that, in a nutshell, is the process I use for creating custom scrapers for removing faceted faces from the beadwork while recreating this colossal crown. And now I clamp down both pieces of crown and go to town, scraping them down. With the pieces firmly clamped down to the work surface, I can get to work with the scraping process, and I use pencil marks across the facets to guide the work as I go, because they're rather subtle. But basically, I just keep scraping till the pencil marks are gone, so I know the contour is clean. As you can see, a sharp burr on even a crude scraper like this quickly shaves off the facets in that surface and leaves a nice clean bead behind. The smaller beads are a little more tricky, but the process is the same, where I use pencil lines to monitor progress and show me when each section is smooth enough and ready for sanding. And I should mention that I chose to do this initial scraping process before gluing the molding together, just because it's easier to work on the pieces with them clamped down flat. And that way, all I need to do after the glue up is some final sanding. So I'll finish up the scraping here and turn the camera back on when I'm ready to join and glue these pieces as a final major step in recreating this colossal crown. I didn't set a timer for the scraping step, but I suppose I spent half an hour, 45 minutes getting everything all smooth and clean and ready to go. So now I'm ready to move on to the next step, which is going to be to glue these pieces together permanently. I spent a little more time coming up with a proof of concept here, showing clamps and wedges, etc. to get this job done. And that's all good, so I'll walk you through the steps that I'll use to get this thing glued up into the finished piece of colossal crown molding. I'll start by flipping the pieces over, backside up, and then putting layout marks about every 16 inches for biscuits I'll use to align and strengthen the joint. I lay out marks on one piece and then use a speed square to draw square lines across both pieces for alignment of the clamping blocks in the next step. Because I'm using biscuits for splines in this joint, the layout doesn't need to be super precise, as long as the biscuit slots themselves are precisely positioned relative to the edge of the piece. Once everything's laid out, I take the pieces over to the bench habit individually and clamp them securely in place while I plunge slots for the biscuits. And how's that for an action shot? It doesn't take long at all to plunge 14 slots in these pieces, so I can slip in 7 number 20 biscuits and do a dry fit to make sure everything's coming along the way it should. While I'm at it, I might as well mention that these biscuits really don't do anything to add strength to this piece, because a well-prepared glue joint is always stronger than the wood itself, but they are invaluable for positioning and alignment of a tricky glue up like this. And that is definitely looking good. For this next step, I cut a scrap of 3/4 inch Russian birch plywood 2.5 inches wide, and then cut 14 wedges with the saw set at 13 degrees to use as clamping blocks in this next step. And now I can go about firmly but temporarily gluing these blocks onto the back of these 2 pieces of crown using my favorite CA glue, Starbond, and I'm using the medium flex version here. And I've marked an X on the sides of the lines where these blocks are going to get glued, so I can apply the accelerator to the back of the crown molding and apply a modest bead of the medium flexible CA glue to the underside of each of the 13-degree clamping blocks. Once accelerator is sprayed and glue is applied, I position each of the blocks on an accelerated layout mark and wiggle it into place before moving on to the next one. And by the time I've got all the clamping blocks positioned this way, that Starbond CA will be set up and ready for clamp pressure. And by the time I'm done gluing up the last pair of blocks, some of the first ones are set well enough for test clamp pressure. And a look at the finished proof of concept that gives me confidence to proceed with the glue up. I took a few minutes to get everything staged here for glue up. I put cardboard down because I want to put plenty of glue in this joint and I don't want to have to clean my tabletop afterwards. I'll be using Titebond 2 glue on this. I could use Titebond 3, but this is what I'm using. Clamps are all laid out, and you might notice these clamp pads on these Irwin F clamps. And those aren't just your ordinary clamp pads. Those are custom 3D printed by EVS 3D Printing, and they're getting their YouTube debut on this video. And the clear filament used to print those pads is kind of a nice upgrade to the black ones that come with the clamps that are kind of meh. So here goes. I'm going to separate everything here and apply some glue. And I'm somewhat rushed here. I'm working late to get this thing glued up so it dries overnight and I can take it out to the job site tomorrow. And unfortunately, sometimes that's a recipe for catastrophe. Being rushed on a glue up seems to invite problems, but let's hope for the best. Because there's enough stress as it is with a job like this after all the time spent prepping the pieces. Don't want anything to go wrong. One reassuring factor on a glue up like this is that these pieces get painted, and so if any problems arise, sometimes filler won't really hurt anything. I don't think I'll need any, but always a little bit reduced stress when doing a piece that gets painted rather than a piece that gets stained, because you can't hide anything with stain. So I've glued all those biscuits in. Now I'll take a brush here and kind of glue the slots on the other side. Get some glue down in those slots. Like I said earlier, the biscuits don't really add strength. They're mostly for alignment, but they will add some strength. So I'll get some glue down in those slots. That should do it. Now I'll just apply a full wet bead all the way along on these edges. And I do like the applicator tip on the Titebond products. There's a slot instead of a hole, and they tends to dispense a pretty decent bead of glue without a lot of fuss. One down each side. I think I'll stick one down the middle because I do want a joint that's full of glue, because the glue is what makes the joint strong. So let's just see if we can get this done without a lot of fracas, like that. This would be a good time to have a cameraman because you could get some close-up action angles of some of what's going on here, but that is not a luxury I have. But this should work out good. I'll start getting some clamp pressure on here a little bit as I go along. There's a fail right there, but we can glue that one back on. I hope not too many of them fail. It's kind of cold in the shop, and I used that Russian birch plywood, and I used medium CA glue. I probably should have used thick CA glue just because the medium tends to soak in a bunch and it can weaken the bond, but fingers crossed, so far more are holding than failing. I already mentioned that the shop is kind of cool, I think, and that gives me extra working time with everything, so it's no big deal. Soak that down with some accelerator. Yeah, this block, the glue kind of soaked in there a little more just because it's that end grain of the Russian birch plywood. It's no surprise. We'll double accelerate this to get it to stick on. It's sticking very well to my fingers there. Give that a second. And I want to get my brush here soaking in some dihydrogen oxide to keep that glue from setting up. That'll work fine. And the dihydrogen oxide works great, but in the right circumstances, that stuff can kill you, so be careful with it anytime you're using it. But we should be good. We'll see. We'll give this another run here for the money. Yeah, that's a good hold. You can see glue is squeezing out all the way along here. It's just what I need. That's a good look. And I'll see if I can flip this over without everything taco shelling on me. And if you can see there, I've got good squeeze out on the inside of this as well. But I will take my negative pattern and kind of put it in here just to make sure. And I think I can pinch this up just a little bit. Those clamps are all on the back. But let's get that taken care of. And viewers of the channel know that I never use water and rags to clean up glue. I just take the bag off my miter saw and use a little of that fine sawdust to soak up that glue squeeze out. And even though I've already said this piece gets painted, cleanup really isn't a big deal, but I'll go ahead and make it easy on myself because nobody else is going to, and clean up most of that glue while I can, while it's wet. So that's looking great, just what I want to see. Yep, I'll put a couple clamps on the front of this. I'll just use squeeze clamps because they'll hang on to those sharp edges without damaging them. It'll force just a little bit more glue out of this face, which is fine. I don't want to squeeze this to the point that it makes the back fail or go too far. But it doesn't take a whole lot of clamp pressure to get this done. I think I'll put the clamps this way. And this is exactly what a piece of recreated Colossal crown is supposed to look like at this stage. Well, this glue up is definitely set up because I had to set this project aside for a couple of days while I did emergency surgery on that door over there, but that's a whole other topic. But now this is ready to remove the clamps and do some sanding so that I can take it for that test fit out on the job site. Once all the clamps are pulled, I use a plastic face mallet and a hardwood block to give each of the temporary clamping blocks a quick wrap, which pops them off the back of the molding with surprising ease to take the clamping pressure needed for the glue up. Next, I flip the piece over and clamp it to the work surface and set about sanding it to remove scraper and saw blade marks so it's ready for paint. I start using 2 different diameters of the round PVC sanding blocks I made in the Next Level Carpentry video a while back. These work perfect for sanding coves on this Colossal crown. When I'm done with the coves, I switch to a small sanding block and sand the 2 smaller beads. Once I'm done with that, I give everything a once-over to remove sharp corners and splinters to soften the overall profile so it better matches the plaster crown molding I'm replicating. Having a full fleet of sanding apparatus like this in my possession makes this job as easy as it can be, but even at that, it takes a good half an hour to clean it all up so it's ready for paint, and further justifies my opinion that I hate sanding. And now with all that dreaded sanding in the rearview mirror, replicating ornate plaster Colossal crown in this 8-foot length of 8-inch wide poplar molding is complete. So now I can just toss it into my truck and head on over to the job site where it's destined to live out a long and meaningful life next to the original plaster Colossal crown I've cloned. And here's the Colossal crown after its one-way trip from the shop to the job site, all sanded, cleaned up, ready to be cut, fit, and installed up here once the remodeling project progresses to the point where it's ready for installation. And it's odd, but I have the strangest feeling like I was just here 2 minutes ago shooting video for making the template for making this crown molding. That's odd because that was actually a month ago. But let me hoist this up there to give you an idea what the plaster Colossal crown molding looks like replicated in poplar. And everybody in show business knows you're never supposed to turn your back on the camera, but there really isn't another way of doing this. But you can see what this is going to look like after final installation. And I think you'll agree that that profile is going to match up nicely when the time comes for final installation. And as you can imagine, final installation is still a ways out. I've got to modify this fireplace by stripping off the existing mantle, building this out, and putting Venetian plaster on there, like this picture from my SketchUp model. And making those changes is going to take a while. But I paused other video production to show you how to replicate Colossal crown, because that's when I was doing it in the shop. And I didn't want to miss this rare opportunity to show what that process looks like and what's possible. So if you find yourself in a situation where you need to replicate a Colossal crown, whether the original is wood or plaster, I hope some of the next level tips and techniques you saw in this video will help you get the job done. And so I'll say, as always, and until next time, thanks for watching. Well, hey, I wondered if a few of you might stick around to the end of this video. So I set this segment aside in the video that you just watched. I just finished cutting the bevels on these two pieces to join them together. And that process really does go just as smoothly as you saw in the video, but I didn't elaborate on the fact that I like to build a little bit of a safety margin into a final cut like that because it's so critical. And I thought anybody that's going to hang around to the end might be interested in this little tidbit, which is basically a safety factor that I like to build into a critical project like this. And I'm going to show you down here on this pattern what I'm talking about and what I do about it. And for what it's worth, content like this is typical of what I include in the patron-only videos on a weekly or bi-weekly basis, where I show the nuts and bolts and kind of an unpolished view of the work. I've got all my stuff set up here, and glasses and earplugs and ring light showing up in the video, which I try to cut out of YouTube stuff, but that's kind of behind the scenes reality from the Next Level Carpentry Shop and video studio. So let me show you these details because that's what you stayed around for. So here's the two test pieces after I made the initial angle cuts at 13 degrees. You might not be able to see it in the video, but there's a small step where the pieces come together. And when I position the pieces against the negative pattern, their combined width is a little too wide to fit the way I want. Using a rule, you can see how the cuts are oriented to the pattern and how the lines show the pieces basically overlap each other by about 1/16 of an inch. This shows me that if I trim a skosh off the bevel of the bottom piece, the two curves will flush up with each other, plus their combined width will fit the pattern like they need to. This shot shows what I need to trim off the bottom piece to get the perfect fit that I'm after. It's less than 1/16 of an inch, but even a little cut like that can make all the difference in the finished product. And this is what I've got after those adjustment cuts. Ended up with a perfect fit everywhere. The pieces are tight together here. When I move them in, they just snap right into that molding just as perfectly as can be. And a little bit of end of the end insight. I actually changed the angle about 1/2 degree on this piece. They were wanting to be open in the front here at the angle I set with those blocks, so I adjusted that angle, and now that's an absolutely perfect fit for the next step. And the good part is I only have to retrim this piece because I made all the adjustments to that cut. This piece just stayed the same rather than splitting the difference, and you can see that here by this line. This piece still lines up with that edge. I left it long, and then this one slid over when I trimmed it off. And that right there is the reason for leaving just a slight fudge factor in projects like this, and basically in any project at all. Because, as I'm known to say, you can cut them off, but you can't cut them on. And I think overall, that is going to be more than acceptable for this Colossal crown molding. And now I can make that final adjustment cut to the actual workpiece and proceed to the next step in shooting the actual video where I work on the biscuit joints and stuff that you already saw in the regular part of the video. And thank you for sticking around to the end, and to the one persistent viewer that keeps politely reminding me I'm actually working on a little bit of swag for end of the end viewers like you, coffee mug, t-shirt, maybe a cap, something like that. So eventually that'll get done. But in the meantime, thanks for sticking around, thanks for watching, and we'll catch you on the next video here or on Patreon. Now that's perfection. Oh yeah.